Chemical properties of amines. There are 4 chemical properties of amine. The first one is reaction with Benzenesulphonyl Chloride, or you can call it Hinsberg Test. Next is reaction with nitrous acid, followed by reaction of aniline with bromine water and formation of azo compounds by coupling reactions. In reaction with Benzenesulphonyl Chloride, or Hinsberg Test, we use to distinguish primary, secondary, and tertiary amines. First, you have to shake the mixture of amine and Benzenesulphonyl Chloride with the excess potassium hydroxide. That's the first step. The second step is add HCl in the first mixture. This is what will happen for primary amine. If it reacts with Benzenesulphonyl Chloride, here primary amine, the amine has 2 hydrogen atoms and it has 1 R group only, so that's why it is primary amine. Reacts with Benzenesulphonyl Chloride, this is the compound of Benzenesulphonyl Chloride. Benzene ring attached to SO2 and bonded to Cl. And then, when you mix these two together, the first step, mixture of amine and Benzenesulphonyl Chloride, these two together, mix them together, the hydrogen in the primary amine, 1 hydrogen atom in primary amine and 1 chlorine atom in Benzenesulphonyl Chloride will be removed to become the side product, and the N in amine will be bonded to the S of the Benzenesulphonyl Chloride. It will become N-methyl sulfonamide. This one, N-methyl sulfonamide. The N will be bonded to S. HCl is removed, so HCl is the side product. Remove H from primary amine, remove Cl from Benzenesulphonyl Chloride. And then after that, when we mix these two, amine and Benzenesulphonyl Chloride, and these two we mix with excess KOH. The second step, take this one, it becomes, if it is primary amine, this product here is white precipitate. Take that white precipitate, mix with excess potassium hydroxide. This white precipitate, the product, when you mix primary amine and Benzenesulphonyl Chloride, the product has 1 hydrogen atom attached to the N. So this is what we call acidified hydrogen. When it mixes with excess KOH, remove this H and the product N-K+, the K from the excess KOH, N-K+. This product is clear solution. This is clear solution. For primary amine, initially white precipitate, when you add excess KOH, clear solution will be formed. Side product water. And then, this side product water, it's from OH and H here. The OH from KOH, H from the N-methyl sulfonamide. This is a side product. And then, this product, the clear solution product, this one, clear solution product, it will undergo the second step, addition of HCl. Initially, mix these two together, react with KOH, and then addition of HCl. After we react the KOH, this clear solution product, add the HCl. When we add the HCl, the hydrogen will replace this K+. Hydrogen attached to N and the side product K+. White precipitate is formed. That's for primary amine. White precipitate, clear solution, white precipitate. For secondary amine, mix these two together, amine and Benzenesulphonyl Chloride. It has hydrogen, remove Cl. So the N and S bonded together, white precipitate, same like this one, primary. And then side product HCl, and then this white precipitate will be added with KOH excess. Notice that this product has no hydrogen attached to N at all. So it has acidified hydrogen. It doesn't have acidified hydrogen at all. So no reaction will happen if you add the excess KOH to this product. White precipitate remain. Okay, the white precipitate remain after you add the KOH. Because N-N-dimethyl-sulfonamide does not have acidified H, so it does not react with excess KOH. No reaction here, remain white precipitate. And then the second step, we have to add HCl. When N-N-dimethyl-sulfonamide add HCl mixed with HCl, no reaction will happen. So this white precipitate remain. From here, white precipitate is no reaction. Initially, white precipitate, no reaction after excess KOH. Again, no reaction after addition of HCl. The tertiary amine. Tertiary amine reacts with benzenesulphonyl chloride. You cannot remove the H because tertiary amine has no hydrogen at all. The first step, we remove H, remove Cl, side product HCl. But for tertiary amine, no hydrogen at all at tertiary amine. So you cannot remove H, remove Cl. So no reaction. So these two mixture remain unchanged. So clear solution. These two remain unchanged, so clear solution. And then no reaction with excess KOH, add the HCl. When you add the HCl for tertiary amine, add HCl, it will become this N will be bonded to the hydrogen Cl minus. Clear solution. So all clear solution for tertiary amine. So if we do Hinsberg test to the different classes of amine, we will get different observation. For primary amine, after addition of KOH, clear solution. After addition of HCl, white precipitate. Here, addition of KOH, clear solution. After addition of HCl, white precipitate. That's for primary. For secondary, after addition of KOH and HCl, the white precipitate remain unchanged. For tertiary, clear solution after addition of KOH in excess, clear solution after addition of HCl. That's for tertiary amine. Nitrous acid test. Previously, Hinsberg test. Now, nitrous acid test. It is to differentiate primary, secondary, and tertiary amines. The nitrous acid, HNO2, is weak, unstable, and always prepared in situ, means during the reaction, in the absence of heat. In situ means when you want to use HNO2, you have to prepare HNO2 during the reaction, not prepare HNO2 first and then react with the reactant. Incorrect. You have to use the HNO2 that is prepared during the reaction. These two are the ways to prepare HNO2. HCl reacts with NaNO to produce nitrous acid. H2SO4 can be used as well to react with NaNO2 to produce nitrous acid. This is what in situ mean. We want to add the reactant CH3, CH2, CH2, and H2. We have amine here. We want to react the amine with HNO2, but we don't prepare HNO2 in advance. We prepare HNO2 during the reaction with amine. So means amine reacts with NaNO2 in the presence of HCl, absence of heat. The temperature must be 0 to 5 degrees Celsius. Not amine plus HNO2, wrong. Amine reacts with NaNO2 HCl because it must be prepared in situ during the reaction. HNO2 must be prepared during the reaction. Why? Because Nitrous acid is weak and unstable. That's why it must be prepared in situ. For aliphatic amines, if it undergoes the nitrous acid test, aliphatic amines means amine with one R group only. Reacts with NaNO2, HCl, here X can be Cl, Br. Okay. The temperature 0 to 5 degrees Celsius. It will produce aliphatic diazonium salt, N triple bond N. This is highly unstable. When this is highly unstable, this N2 will be released. N triple bond N, it will be released because it is highly unstable. So this is not the final product. Aliphatic diazonium salt is not the final product. The N2 will be released and the product will become R plus X minus. Okay, this R plus X minus R plus. Alkene can be formed. Alcohol, alkyl halide from X minus, alkene from R plus, and alcohol and alkyl halide. So, if aliphatic amines undergoes the nitrous acid test, the products are alkenes, alcohol, alkyl halides, and nitrogen gas. 4 product, nitrogen gas side product. Okay, these 4 product will be formed when aliphatic amine undergo nitrous acid test. This is the example. 1 propanamine, HNO2 prepared in situ. So NaNO2, HCl 0 to 5 degrees Celsius. The product will be alkene, alcohol, alkyl halide, nitrogen gas release. Arrow pointing upward, nitrogen gas is released. So here, look at the carbon number, 3 carbon. In alkene 3 carbon, in alcohol 3 carbon, in haloalkane 3 carbon as well. Even at low temperature, aliphatic diazonium salt decomposes spontaneously by losing N2 gas, nitrogen gas, because diazonium salt, aliphatic diazonium salt is highly unstable. So that's why it becomes alkene, alcohol, alkyl halide, nitrogen gas. For aromatic amines that undergo the nitrous acid test, for example, aniline, NaNO2, HCl 0 to 5 degrees Celsius temperature, it will form aryl diazonium salt. Aryl diazonium salt, the N triple bond N, N plus, Cl minus. Okay, the N plus is this N, Cl minus. So this is aryl diazonium salt. Aryl diazonium salt is far more stable than alkyl diazonium salt. But we have to keep it below 5 degrees Celsius, this product. Okay, N triple bond N, N plus, this N plus, Cl minus. That's for primary aromatic amine. For secondary aliphatic amine, the amine that has 2 R groups, that is secondary, undergoes nitrous acid test. The product will be N-nitrosamine, nitrosamine. N-nitrosamine is this N with 2 R group, N with 2 R group, and then here remove the hydrogen, replace with NO, N double bond O. This nitrosamine is yellow oil. This is yellow oil. For secondary aromatic amine, for example, N-methyl aniline, this is secondary aromatic amine, means N that attached to benzene ring has 2 R groups, undergoes the nitrous acid test. The product is N-nitroso N-methyl aniline. This is yellow oil. Means remove hydrogen, same like before, remove hydrogen here. Secondary amine, remove hydrogen, replace with N double bond O. Same, remove hydrogen, replace with N double bond O. This is yellow oil. Okay, yellow oil. For tertiary aliphatic amine, N that has 3 R groups, undergoes the nitrous acid test. The products are amine salt and HR3, the N is plus. HR3 N plus means this NR3 it will receive 1 hydrogen. Okay, this is amine salt. The plus is at the end, it will receive 1 hydrogen. This reactant will receive 1 hydrogen and N plus. Okay, plus NR3, one more NR3, bonded to N double bond O, NO. So this is nitrosoammonium. Nitrosoammonium decomposes to produce aldehyde and ketone at high temperature. This nitrosoammonium can decompose to produce aldehyde and ketone, but the temperature must be high. For aromatic amines, here aromatic amine, tertiary aromatic amines, N has 3 R groups, and one of the R groups is a benzene ring because it is aromatic amine, tertiary aromatic amine. Undergoes nitrous acid test. Product is N,N-dimethyl 4-nitrosoaniline. Means this reactant will get the addition of N double bond O. N double bond O must be attached at para position here. It must be attached at para position. This is in green precipitate, green in color. The tertiary aromatic amine undergoes nitrous acid test. The product will be reactant with addition of N double bond O at the para position. Why para position? Undergoes electrophilic substitution with nitrous acid, so add an O but replace the H hydrogen, so this is not addition because we have hydrogen here. N double bond O replace the hydrogen, so electrophilic substitution with a nitrous acid. The product is para because bulky dialkyl amino group. So here, if you look at here, this nitrogen has CH3, CH3. So it's hard for N double bond O to be attached here because it is bulky. Hard to attach ortho, difficult to attach at meta, so it prefer para. So that's why the product of substitution N double bond O, it substitute the H here, it must be at para position due to bulky dialkyl amino group block approach of nitrosonium ion to the ortho position. So it cannot be at the ortho position or meta position. It prefers at para position. This is nitrosonium ion. Summary of nitrous acid. Primary alkyl amine or aliphatic amine, primary aliphatic amine, nitrogen and other mixture of product, alkene, alcohol and alkyl halide. Okay, for aromatic, primary aromatic, diazonium salt is stable below 5 degrees Celsius. Primary aliphatic amine, nitrosoamine, primary aromatic amine, and nitrosoaniline because it has benzene ring in there. Yellow oil for both yellow oil. And then tertiary aliphatic amine, amine salt, and N-nitrosoammonium. Tertiary aromatic amine, para-nitrosoaniline. This is green precipitate. Okay, green precipitate. Next is the reaction of aniline with bromine water. NH2 is very powerful activating group and powerful ortho para director. So it will direct the substituent to ortho and para. Aniline reacts with bromine in water at room temperature. So aniline react with bromine in water at room temperature. Decolorization of bromine water occurs and a white precipitate. So we know that bromine water, bromine color reddish brown. The reddish brown color of bromine will decolorize and white precipitate will be formed. The white precipitate is the product of 2,4,6-tribromoaniline. 2,4,6-tribromoaniline. Why the position is 2,4,6? Because NH2 is very powerful activating group. NH2 is very powerful ortho para director. This NH2 powerful ortho para director. So it will be at ortho and para. No bulky group because NH2. So it can be at ortho and para. So the product must be at 2, 4, 6, no other position, and it is what? Precipitate, 100%. Final reaction of amine is coupling reaction of diazonium salt. This is diazonium. Aryl diazonium ions reacts with phenol or tertiary aryl amines to yield azo compound. So this is aryl diazonium ion. The aromatic ring, benzene ring, attached to N triple bond N X minus. This N plus the X minus halogen atom here. Halogen atom minus N plus this N that is plus, not this N, the N that attached to the benzene ring. Reacts with, if this G is OH, it is phenol. If this G is NR3, it is tertiary aryl amine. So this aryl diazonium ion can react with phenol or tertiary aryl amines. Okay, benzene ring attached to OH or benzene ring attached to NR3. So azo compound will be formed as a product. Hydrogen atom, one hydrogen atom will be removed from this tertiary aryl amine of phenol, and one X atom will be removed from diazonium ion. So remove X, remove H at the para position. Remove H here, remove X here, attach those two together and attach to the carbon here. So this N triple bond N will become N double bond N. Okay, new bond will form. So it will become azo compound. This N bonded to this carbon. Okay, this N bonded to this carbon, and this triple bond becomes a double bond. So this is azo compound. Azo compounds are usually intensely colored and relatively inexpensive compounds. That's the final reaction for amines. Thank you.